S-Chan presents Educational Video Lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
In the given system, when there the large number of atoms are present, so the large number of waves are associated with the particles or all the atoms. So these waves are represented in terms of bunch of waves or the wave packet.
If you want to study this topic in detail, refer to the book by S-Chan Publishing. Link is provided in the description box.
Myself, Dr. Narendra Kaur, welcome to S-Chan Academy. Now I will explain you what is a group velocity, the velocity which is associated with a wave packet, and how we can represent this wave packet. So now what is a wave packet over here? So wave packet, that is defined as an envelope or the packet which contains the number of planes waves having different wavelength or the wave numbers. That means wave packet is a bunch of waves. We know that the waves are in the system, there the large number of particles are present. So with each and every particle, the waves are associated, and these waves are combiningly known as bunch of waves or the wave packet. So the wave packet, that is the envelope or the wave packet which contains a large number of planes wave. They are having the different wavelength or the wave numbers. These numbers of the wave, they will superimpose on each other because we know that they have a different wavelength. So all they will superimpose on each other, so they can give us a constructive or the destructive interference over the small region of space and the resultant wave that will be obtained. So this resultant wave, that is known as the group wave, and the spread of amplitude of the resultant wave with distance determines the size of wave packet, and the wave packet, that is also known as wave group. So now this is a theoretical definition of wave packet. That means the large number of waves, these are associated with the particles and they will superimpose on each other to give us the resultant wave. So that resultant wave is known as wave packet. Now how we can see that the wave packet means, now if there are a large number of particles are associated, so that means now if this is a wave which is associated with one particle, again now this is a wave which is associated with a second particle. Now these waves, they have a different wave number. So what is wave number? That is a reciprocal of frequency, that is known as the wave number. Now the different wavelength, again, so they can be like this. So these are the waves. Now particles, they can, depending upon the energy which is associated with the particle, all these particles, they can move with each other. Now this is the, now if this is the first particle, second, third, and so on. So there are the large number of particles. Now the wave which is associated with the first particle, this is known as the phase, and the velocity associated with this particle, that is known as the phase velocity of first particle. Now velocity of the second wave, that is known as phase velocity of second particle. So that means each and every individual particle, they have waves associated with them, and automatically they are having the phase velocities of these waves. Now we know that in the given system, there is not a single wave. So there is a bunch of waves. All these waves, they will superimpose on each other, and the bunch of waves, they will form a packet, and that packet is known as the wave packet, and the wave which is associated with this packet, that is known as a group velocity, or the group of waves are present over there. So that means we know that now all these waves, they will superimpose on each other. So that means now there are a large number of waves which are present over here. So now these waves, when we superimpose all these waves, so they are with different phase, with different amplitude and the different wave numbers. Now all these waves, they will superimpose on each other. We know that there occur two types of interference. One is a constructive interference and second one is a destructive interference. Now what is the meaning of constructive interference? Means when there is a superimposition of these two waves, now if the positive lobe of one falls on the negative of one, positive of one, now in this case the amplitude that will be higher over here. So this kind of interference is called constructive interference, means their phase is same over here. So that means in this case there occur the constructive interference. So in the resultant wave, that must have higher amplitude than the individual waves. So the resultant wave, so here the resultant wave that will have amplitude more than these two waves. Such kind of interference is called constructive interference. Now next is a destructive interference. So destructive interference means when the waves superimpose on each other with the opposite phases. So if this is a first wave and that is a second wave. So in this case, when they superimpose on each other for the resultant wave, so depending upon the amplitude, which wave has the higher amplitude. So let us suppose that it has a higher amplitude. So the resultant wave that will have the smaller value. So this implies, so there occur either constructive or the destructive interference depending upon the phases of the wave which are superimposed on each other. So that means there are large number of waves which are superimposed on each other. So all these waves, this is called the bunch of waves. So that is called the group of the waves or the bunch of the wave. And or the bunch of these waves, they will travel with some velocity. That velocity is known as the group velocity. And these bunch of waves, they are just equivalent to the single wave. Now how you can represent this? So that can be represented like this. That means these bunch of waves, they are also equivalent to single wave. So that means now these bunch of waves that can be represented like this. So if this is the velocity over here, that means now these bunch of waves, they are just represented like this. That means it appears like that a group is traveling over here. So this is known as group of waves or the bunch of waves, or this group of waves or bunch of waves, that is known as wave packet. Now we want to calculate the velocity of that wave packet, because the complete system, the entire system, in the given system there are the large number of atoms or the large number of particles are present. All these particles are vibrating with some velocity. They are oscillating with some velocity, and the waves are associated with each and every particle. And due to that waves, there occur superposition of all these waves. All these waves on superimposing on each other, they will represent a bunch of the waves, and that waves are represented in terms of some packet that is known as wave packet. So this is known as a wave packet over here. So next is the group velocity. Now what is the group velocity? Now we know that the velocity of propagation of wave packet, we know that the wave packet that will travel with some velocity, that velocity is known as group velocity. So what is wave packet? Wave packet is known as that is a combination of all the waves which are superimposed on each other. Either there must be constructive interference. So means when in the some part, when there is a constructive interference, the resultant wave that will have higher amplitude. And when there is a destructive interference, the resultant wave will have the smaller amplitude. So that means this bunch of waves, now this bunch of waves that can be represented in terms of, so this bunch of waves is also equivalent to a single wave. So now the velocity of this bunch of waves, that is equals to group velocity. So group velocity that can be also represented in terms of velocity of the energy flow. We know that when some system moves, the energy is transferred from one region to the another region. That means a group of particles or the group of waves, they are traveling in the given system. So the energy of the system that is transmitted from one region to the another region. That means all the particles, they will travel with some single velocity. that velocity is known as phase velocity, or you can say that group velocity Vg, that is equals to the velocity of the energy flow or the transmission of information in the given system or in the given packet, that is equals to Vg. So, the group velocity, that is equals to derivative of omega with respect to k. We know that is a different from phase velocity, which is equals to omega by k. What is omega here? That is a angular frequency, and k, that is known as a constant or propagation constant. Now, depending upon that, we know that when we calculate this relation for the single wave, this velocity, that is equals to c square by v, that is not possible. We know that is not possible over here. So, we are taking the concept of group velocity, that means whole system that is traveling with a single wave. All the waves, they are superimposed on each other. So, there must be higher amplitude is there when there is a constructive interference, or they can be with a lower amplitude. So, whole system that can be represented in terms of a single wave. So, that is equals to group velocity Vg, that can be written as d omega by dk. That means the rate of change of angular frequency with the, this is the propagation constant. So, that means with the propagation constant, all the waves, they are propagating in the single phase, in the single direction. So, with the different amplitudes, either there is a higher amplitude or the lower amplitude. So, the angular frequency of the wave packet, that is changes with respect to propagation. So, that is why we are taking here derivative with respect to k. That means the angular frequency, that is goes on changing with respect to some propagation constant, which represent the movement of the wave over here. So, this term is defined over here, that is known as a group velocity, which is equals to the velocity of the energy flow or the transmission of information of a traveling wave or the wave packet. So, that means traveling, why there is a written as a traveling wave? That means the whole of the wave packet that can be represented in terms of a single wave, means the bunch of waves, they are just equivalent to, or they are just represented in terms of single wave. So, that is why we are writing here a traveling wave, and that means the information from one part that is transferred to the another part. When the particle transferred its information from one to another part, so there comes and its velocity that can be represented in terms of group velocity, that is equals to Vg. So, this is the velocity of the wave which is associated over here. Now, we will take a short break over here. So, till now we have understood what is the group velocity, how there comes a terms of the concept of the group velocity, because there is a wave packet, and with the wave packet some velocity is associated. There are the large number of waves which superimpose on each other to give the resultant wave, and the resultant wave is represented in terms of wave packet. Now, after the break, we will derive the mathematical expression for the group velocity.
Now, quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy. Now, after the before break, we have studied what is a wave packet and what is the group velocity associated with the wave packet. Now, the mathematical expression of the wave packet, that will be derived over here. So, now mathematically how we can calculate the group velocity. So, group velocity is a basically combination of group velocity, that is a basically what is a wave packet? That is a combination of more than two waves or more than one wave. So, that means when these waves superimpose on each other, after the superposition we will get the resultant wave, and that is equals to the velocity associated with that is known as the group velocity. Now, the expression for the group velocity that can be calculated as, now let us consider a simple harmonic oscillator is considered over here, and in order to derive this in the simple way, we are considering here only the two waves. Let us consider the two waves, and they are traveling with some phase difference, with the same amplitude and the slightly different in the wavelength, or you can say that slightly difference in the phase difference over there. So we are considering here the two plane simple harmonic waves with the same amplitude and slightly different wavelength traveling simultaneously in the positive x direction. Means they are different to each other with small, there is some phase difference between the two waves. So the displacement for the first wave, that can be represented as a sin omega t minus kx, that is for the first one. And for the second one, now there is a amplitude is same. So these two waves, now single, instead of single wave, for the in the wave packet we are considering here the two waves. Now these two waves, they will superimpose on each other. Now the amplitude of these both the waves, now the wave that can be represented by the displacement factor, some displacement that is equals to combination of phase as well as amplitude. So the wave that can be represented as a sin omega t minus kx. So this is the first wave. Now the second wave has same amplitude but a difference in the phase. So now slightly difference in the phase, that can be represented by the delta omega, and the propagation constant, there becomes a delta k. So these are the two waves. Now from the superposition principle. Superposition principle means now these two waves, they will superimpose on each other. Either there comes constructive interference or there comes a destructive interference. So depending upon the phase, when they are having the same phase, there will come a constructive interference, and when they are having the opposite phase, there will be the destructive interference. Now for the constructive interference, so the resultant amplitude, that will be sum up for these two. So the resultant wave, that can be written as a sin omega t minus kx, this is for the first wave, and that is for the second wave. Now again, so this, there comes the formula of sin c plus sin d, that is equals to 2 sin c plus d by 2 and cos c minus d by 2. So now here we will get, now this is equivalent to y is equals to a sin c plus sin d. Now apply the formula of, mathematically apply the identity formula, that is a sin c plus sin d. When we apply this formula, we will get this is equals to 2a sin c plus d by 2 and cos c minus d or d minus c by 2. So when we apply this formula over here, here in this case c is omega t minus kx, here the d is omega plus delta omega into t minus k plus delta k into x. So now this is d over here and that is a c. So when we apply this formula over here, we will get, this is the resultant amplitude, that will be equals to 2a sin omega t minus kx cos of this one. So this is the, now we will get this expression. Now again, so this is the equation number R. Now this is the analytical equation for the group of waves. That means a bunch of waves or the group of waves, that is for the two waves. So that can be represented by this. Now when we are taking the summation for the three component, so there comes another component also. Then again we will apply the formula of sin c plus sin d. Now that means this is a combination of these two waves, so that will represented here. Now the resultant wave includes a two component. Y is equals to 2a sin omega t minus kx. Now omega t minus kx, that means the resultant wave has the same phase. So in the resultant wave, there are the two components. One component has the same phase as that of the original wave. So that means the sign factor represents a carrier wave that travels with the phase velocity or with the same velocity. And second, the amplitude of the resultant wave, that is same. So this is the same amplitude of the resultant wave. So the group velocity, that can be represented like this. Now the resultant wave means the after superposition. Now this is, we will represent the same component as that of the single or the individual wave. So the resultant of these two, that can be represented in these terms. So that means the amplitude is the, like we know that the wave, that is a combination of amplitude into sine of omega t minus kx. Now when we compare this with this relation, so this is equals to, now sine omega t minus kx, this is the factor over here. So the amplitude will become 2a cos half of this factor. So that will give us the resultant amplitude. Now depending upon the constructive interference or destructive interference, this amplitude that can be maximum or that can be minimum. Now when the amplitude is maximum, now how this factor that can be maximum? We know that the value of this cos theta for maximum amplitude means we know that the maximum value of cos theta that is equals to 1. So cos theta that is taken to equals to 1. So this is a maximum amplitude for the factor. So now that means this will be equals to 1. So that means the resultant amplitude of the wave factor, now this amplitude, now if this is equals to 1, so that will become 2a. What is Rm? That is a resultant maximum amplitude. So that can be calculated over here. Now next is the, now from the given equation, put this is value equals to 1. We know that now this is equals to 1, cos is maximum value is 1 when it is 1, when this is 1 when theta is equals to 0. So this is equals to 0. So now on comparing this two, this cos, this is equals to cos 0. So that means theta will be same on both sides. So that is equals to 0. So now group velocity that is equals to delta omega by delta k. So this is the expression for the group velocity. So that means group velocity that is equals to d omega by dk. Thus the maximum amplitude that is the center of the wave packet that is moved with d omega by dk, and that is known as group velocity. So that means for the given system, group velocity that can be represented as d omega by dk. That means instead of single wave, the bunch of waves that are associated with the moving particle in the given system. Now next, how you can derive this expression for the group velocity. That means the group velocity that can be represented by this relation. So group velocity that is equals to d omega by dk, which is equals to Vg. Also the group velocity that can be written as minus lambda square into d omega by d lambda, d mu by d lambda. What is nu here? That is the frequency of the wave and lambda is the wavelength of wave. So now in order to derive this expression, we know that the omega that is equals to 2 pi nu. Omega that is angular frequency. What is nu here? That is the frequency of the wave. And what is k here? That is the propagation constant that is equals to 2 pi by lambda. Now on deriving this value over here, we know that here the derivative of 1 by lambda that can be written as minus, now its derivative that will be equals to minus 1 by lambda square. So that is a derivative of 1 by lambda. So substituting this value over here, or that will be equals to d lambda because there is a no variable over here. Now substituting this value over here, we will get group velocity that is equals to minus lambda square into d nu by d lambda. So this is the expression for group velocity. Now we calculated over here. So group velocity that can be represented as d omega by dk, or maximum value you can read d lambda d nu by d lambda. So this is the expression for group velocity. Now for the phase velocity, its expression is c square by v. That means phase velocity, that is the wave or the velocity which is associated with the single wave which is associated with the moving particle. Means when the velocity of the particle v is equals to, it is always less than c. That means phase velocity is greater than c. So that is not possible. So that's why there comes a concept of group velocity. So according to group velocity, now that is equals to d omega by dk. Now this is always less than or equals to c, because when we are taking for the light waves, that is equals to c. So there comes group velocity. That means for the moving particle, the large number of waves which are associated with the particles. So the information is transferred in the given system from one region to the another region. So when the information is transferred, so there are the bunch of waves or the packets which are associated with the moving particle. And due to presence of these bunch of waves or the bunch of particles, present a bunch of waves which are present in the moving particles in the given system, they represent a single packet, and that packet is known as the wave packet, and velocity associated with that packet is equals to Vg, which is equals to group velocity, and that is always less than equals to c. So that means mathematically when we are defining the concept of group velocity, that is true, because group velocity is always less than velocity of light, that is a maximum velocity that any system that can attain. While in the phase velocity, that is a velocity which is associated with a single wave. That is not possible because c square by v, this expression is equal to c square by v, and v is a velocity of a particle. We know that any particle that can never achieve the velocity of light, v is always less than or equals to c. So automatically Vp, that is always greater than c. That is not possible. So that means in the given system, all the waves, they will superimpose on each other either constructively or destructively depending upon their interference. We are getting a resultant packet, and the resultant velocity associated with them, that is represented in terms of Vg, which is called the group velocity. So concluding this topic, we are getting the information why we are taking the concept of group velocity, not the phase velocity. As the phase velocity is a wave velocity of the wave which is associated with a single particle and which is more than c, that is not possible. So that's why there comes a concept of group velocity. Thank you.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.